This is the Unit 12 review video. This is the last unit of the textbook. You've done it. Congratulations. I feel bad that this is the last of it, but all good things must end sometime. Alright, here we go. Unit 12 test review. These problems are similar to the problems that you're going to see on the Unit 12 test, so if you understand these, you'll be in good shape and you won't be surprised by any of the problems that are on the actual test. Alright, let's start with this one. I have a pair of intersecting lines and I have one angle given at 55 degrees and I'm asked to find the measure of angle 1. Well, those are vertical angles, and we know that vertical angles are congruent, so if the measure of angle, this angle is 55, the measure of angle 1 is also 55 degrees. Problem 2, angle 1 and angle 2 are supplementary angles. That means they add up to 180. If the measure of angle 1 is 72 degrees, find the measure of angle 2. Well, it would be 180 minus 72 degrees, which would be 108 degrees for the measure of angle 2. That was pretty straightforward. Remember, two angles are supplementary if their measures add up to 180. Alright, now here I have a pair of parallel lines. You can tell they're parallel, cut by a transversal. Name one pair of alternate interior angles. Inside different sides of the transversal, I'm looking at 3 and 5. I'm going to say angle 3 and angle 5. That would be a good answer, as is angles 4 and 6. Those are alternate interior angles also. So either one of those. Problem 4, use the diagram here, and it says that the measure of angle 2, that's this angle right here, is 140 degrees. Find the measure of angle 6. Well, the measure of angle 6, these are corresponding angles, and they're congruent. So the measure of angle 6 is also 140 degrees. Very straightforward. Problem 5, what is the measure of an interior angle of a regular hexagon? Hexagon, remember, has 6 sides. The sum of all the angles would be 6 minus 2 times 180, which is 4 times 180, or 720. But since we're trying to find the measure of only one of the interior angles, remember it's regular, so they're all the same size, all 6 angles have to divvy this up evenly, so I'll divide by 6 and I will get 120 degrees for the measure of one interior angle. Problem number 6, over here I have a quadrilateral drawn, and I have an exterior angle marked at each vertex. Only one. We know that the sum of the exteriors add up to 360. We're to find x. Well, let's say x, that's this one, plus 75, plus 60, plus 125 has to add up to 360. 75 and 60, that's 135, 135, and 125, that's 260. So now I'm going to solve for x. I'm going to subtract 260 from both sides. And I get x is equal to 100 degrees. And that would be the measure there that we're looking for. Alright, in problem number 7, I have a right angle with an extra ray drawn in that breaks that into 2 angles which we know are complementary. They have to add up to 90 degrees. So that means this angle and this angle, that means 2x plus 3x plus 12 has to add up to 90 degrees. Now we're supposed to find x. Combine like terms, that's 5x plus 12 equals 90 degrees. I'm going to subtract 12 from both sides. I don't think this one's going to come out evenly. That's okay. 5x equals 78. Now I'm running out of space, so I'll bring it up here. 5x equals 78. I'm going to divide both sides by 5, and I get x equals 15.6 if I break it out on a calculator. 78 divided by 5 is 15.6. Problem number 8. Are angles 1 and 2 complementary if the measure of angle 1 is 65 degrees and the measure of angle 2 is 115 degrees? Well, they're complementary if they add up to 90 degrees, and this isn't going to do it. You can see this one's already more than 90 degrees. In fact, they add up to 180 degrees. So they're not complementary. The answer is clearly no. They're supplementary, as it turns out. The last example here got kind of cut off, so I'm going to work it up here. But it says, how many lines of symmetry does an equilateral triangle have? So I'm going to do my best to draw an equilateral triangle. That means all three sides are the same measure. And I believe if I bring one down like this, if I bring one across like this, and if I bring one through like this, you will see that I have three lines of symmetry that I can draw in here. Alright, so make sure you look these over and get ready for the test. Practice, practice, practice.